This conference will now be recorded.
Analyst, ma'am?
Yes, sir. Shall we start, sir?
Yes, madam. We'll start.
Okay, sir. Very good morning to all. With the blessings of our founder, Colonel Dr. Jeppiaar, sir, I welcome you all for the final session of 5 days faculty development program on machine learning and cloud infrastructure organized by the Department of Computer Science and Engineering, Jeppiaar Engineering College, in association with Institute Technologies Private Limited, Chennai. Dear participants, we request you to kindly mute your audio during the session. At the end of the session, you can unmute yourself and you can clarify your doubts. Else, you can type your queries in the chat box. Now, I request our head of the department, Dr. J. Ranjit sir, to deliver the welcome address.
Happy morning to one and all. So I feel immense pleasure in welcoming Dr. Anandarajan for today's session. So research perspective, machine learning using Google Colab tool. So, so very interestingly, we have passed 4 days learning experience. So this is not only your learning faculty development program. You would have all the participants. You would have got a lot more other opportunities. Still, we are very happy that we are part of your learning experience. So 4 days, our association with you people were tremendous. So we all learned a lot. So I hope this faculty development program would have enriched you with a lot of skill set, lot of research opportunities would have been explored, and lot of information that were in your mind, but so still you had a lot of doubts, so it would have been clarified by the speakers. So today's speaker particularly is going to handle on Google Colab. So this is last day. So, but this is not the last day of our association. So we will have this learning experience together in future also. I feel very happy to welcome the speaker, Dr. Anand, and all the participants, professors, HODs, and everyone who have shown the interest in our 5 days faculty development program on machine learning and cloud infrastructure. I thank international participants from Philippines and women who have really shown their interest in learning through this faculty development program. So our management, I really every day during my speech, remembering my management. So their support is tremendous. So they have motivated us like anything. So the organizers have well organized, planned manner. They are moving this faculty development program. So everything seems to be very good for a very good learning experience environment for we people during this lockdown. So I thank God for creating this opportunity. So I welcome you all for this 5th day of 5 days faculty development program on machine learning and cloud infrastructure. And I hand over the session to the organizers for further proceeding.
Thank you, sir. Thank you, sir. Now I request Dr. Beulah ma'am to address our today's guest.
Thank you, ma'am. On behalf of the Department of Computer Science and Engineering of Jeppiaar Engineering College, we welcome Dr. Anandarajan for this 5th and the final day of this wonderful faculty development program. Dr. Anandarajan is currently working in JP College of Engineering, Tenkasi, which is a beautiful town situated in South Tamil Nadu. He is an associate professor in the Department of Electronics and Communication Engineering. He completed his master's in applied electronics, followed by doing research in the Department of Information and Communication Engineering from Anna University. He has 6+ years of experience in teaching and 5+ years of experience in research. He published more than 30 papers in well-reputed national and international high-quality journals and effectively participated in many national and international conferences. He is an active member in IAENG, IACSIT, CSI, ICSES, ISRD, SWIDC, and many more. He was awarded with the fellowship grant of 10 lakh rupees for the project titled Energy Efficient Cloud Data Centers. His projects used to be get selected for Tamil Nadu State Council for Science and Technology projects every year, and his successful journey continues. So today we are presenting Research Perspective on Machine Learning Techniques using Google Colab by Dr. Anandarajan. A warm welcome to you, sir, and I hope your informative session is going to create an impact for the teaching community and people who are doing research. Welcome you, sir. Over to Dr. Anandarajan.
Good morning, ma'am. Am I audible, ma'am? My slides are visible.
Yes, sir. Your slide is being audible. Yes, sir.
Yes, ma'am. Yes, ma'am. Thank you, Dr. Ranjit sir and Professor Beulah ma'am for your kind gesture. I would also like to thank the organizers for getting me into this prestigious webinar session. So, with this, let me proceed with the with today's discussion. So, today's topic is research perspective on machine learning techniques using Google Colab. So before starting, let me first give a discussion about how we have to proceed with the research in terms of machine learning techniques. So a lot of research is already going on, and we are in the highest value of the research going into the prototype modeling. So we should take care of how a validated research can be further proceeded towards a better research arena in this particular area called machine learning, because we know that deep learning is coming up and a lot of research is already going on deep learning. We have to concentrate on certain specific mathematical techniques, mathematical modeling techniques that are very crucial in terms of how machine learning can be taken further towards research perspective. So before going into these slides, we should basically understand machine learning is a paradigm of different mathematical techniques like topics like linear algebra, statistics, probability, and partial differential equations. So how we are going to apply these mathematical techniques into a particular real-time problem and create a better solution for those real-time problems which day to day is faced by various verticals like health, education. Okay, so there are a lot of problems that are arising which involve data, because data is we all know that like data is a new oil, and it is creating a lot of opportunities for new engineers and how the projects are being developed in terms of how we look at data as such. Okay, so with this, let me proceed with the next slide. So we all know that the editors in different journals, because I would like to start with respect to the research perspective, where the journals are in terms of the standards are very important for any individual faculty to get themselves recognized for their future career. So here, if we can see, the statistics says that 27% of the papers are not cited. So the zero citation is cited articles is getting increased day by day. So how do we reduce that? How do we face that particular issue which is faced by the editor of different important journals? Because what, in terms of the editorial perspective, an editor always expects their journal to be cited in many ways in different domains, so that it is far reachable to different areas of the research as such. So for this, we should look into the higher cited articles, how it is done, what are the design perspectives, how is the mathematical modeling taken into the particular problem, and how it is being solved is very crucial in terms of how a higher cited article can be published in a better journal. So for this, we should look at the challenges that are being solved. Okay, so the challenges are very important. The opportunities that are brought up from the real world problems becomes the challenges for each researcher to solve in terms of the method or the algorithm that we are going to apply. Okay, so in terms of the plagiarism message, because plagiarism plays another important role with the zero-cited articles, where the articles which are not cited majorly fall under problems where it is not able to reach a vast audience. And plagiarism also plays an important role where the articles are being disqualified. So we should be very careful in terms of plagiarism, and also what is the hot research topic and how it is being solved with different algorithms. Okay, so it is very crucial in terms of the originality and the relevance with respect to the updated new hot research topics. So why do we have to do research? So we all know that the real-time projects addressing societal issues, which are very important in terms of how a knowledge-based economy can be developed, because the GDP is going to be focusing on knowledge-based economy for different countries. So we should be very crucial that as a country, as a nation, we should be able to retain and create high quality education. For that, we need high quality faculty, where the faculty should be able to solve new research problems and give it as a perspective for the students, for them to learn using open source research. Because we all know, we all keep on complaining about research infrastructure that is being given by the college. These complaints, these drawbacks should be overcome by the open source research as such. So the importance of publications is very important in the career of any faculty. So how we plan this particular journey is very important. What are the skills to be acquired is very important. How do we strategize a particular the skill to apply for a real-time problem and win that particular problem by giving a better solution? Because solution can always keep changing, and it is evolving towards the better research. So we should always keep on thinking critically in terms of how we can solve those problems, and keep on asking questions, and keep on publishing new ideas in terms of how the society needs that particular problem to be solved. So it is very important for us to understand where we are going to publish and what we are going to publish, and what are the journals that are there in that particular scope. Because many journal papers which are arriving to the editor find those papers not in the scope of the aim of the journal. So we should always look into the aim of the journal, look into the scope of the journal, and then publish in that particular journal. So it is very necessary to fine tune our the idea, and also find a particular area in which this particular paper can be published. So challenges in growing research, that as I already told you, the complaints that we make becomes those challenges. So we all know some institutions don't have proper institutional infrastructure. Some have limited scale and critical mass. Some have the academic staff often they don't understand, or they don't try to forecast what is a research problem and how do we solve it in terms of the industry and the academic gap. So we should always try to find the gap between them, and try to address those particular problems, and try to bring that to the students, so that the students will get more enlightened towards solving real-time problems. So these are different problems that are arising, and a trade-off between the academy and the industry itself. So before writing, we should have an attitude of how we can develop a particular research paper. Okay, so we should have a particular gut feeling that this problem can be solved by me, and what it is worth investigating at this point in time. So this is very important at this juncture, because there are a lot of problems that are arising. So we should define a particular problem in a way such that the hypothesis that is evolving from those from the different mathematical modeling or the algorithm that we're going to apply will formalize to a particular research design, which can be used by different literature, and evolve the particular research to a better standards. So we should always be very careful before even writing the paper to understand the flow of ideas, to understand the presentation strategy, to understand the discussion of the results, how it should be done. So all these things should be taken care even before writing the paper in terms of your own brainstorming. So there should be a lot of brainstorming sessions, a lot of questions being arised, and we should keep on writing something, because when we look at a career of a faculty, it should be focusing on academics, projects, patents, and there should be different ways of applying for different research projects as well in different good organizations like DST, DRDO. So we should keep on applying those projects. So further, basically, what should we start doing is start writing. So without writing those ideas in a notebook, without writing the ideas with in a pattern of discussion of the questions being arised in your mind and with the students and with the faculty, the faculties that are there with us as colleagues, we should keep on discussing those ideas and evolve with different discussion of results, because these discussions will sometimes flourish into a better idea which the journals expect. So finding the right quality of journal is very important. Okay, so we should always look at a journal with a better quality in terms of the impact factor. Okay, so there is always a trade-off between the quality and time. When we all start writing a paper, we always look at the time, because we want to complete the paper as soon as possible. But that is not the way we should do. We should look at the quality as well, because when we are going to compromise on quality, the time will probably, it is not going to provide you with better research. So we should always look at spending more time on a certain thing to reduce this particular trade-off between quality and time. So the response time of editors is also very important in terms of how the papers can be published as fast as possible. So it is usually in most of the journals there is response time given as submission to first decision. So they will keep on, they will give the certain number of days within which they're going to give you the first decision. So that is very important before you are applying for the journal. And also try to find people and contact them with respect to how they publish their papers in that particular journal, because there are a lot of authors in the particular journal as well, which you can find in Google Scholar. Okay, so quality or quantity. So we should decide what is important, because there are a lot of people publishing a lot of papers, but quality is also very important in terms of a good quality faculty or researcher. So importance of quality is very, very important. So avoid working with editors who are working slowly, who will take long time to submission to first decision. So we should always be very careful with those small important things to be noted down. So when you are going to start writing a paper, always remember this is the flow with which we are going to move, and it should start with the literature, where there will be a lot of tables and comparisons, and then you go with the experiments, because experiments is very important in terms of tool. So when I talk about tool, the Google Colab or any open source tool will help you in getting results faster, because when we want to work on Python, we all know that we need a particular test bench or a tool to work on. So Jupyter, there are a lot of tools that we can work on, but installing takes some time. We all know that it is going to take some time. We all know that the data is going to be segregated everywhere. So we have to have a data set in a particular area. Okay, we should also have the data up and running every time you want to, you have an idea and you want to implement. So open source tools like Google Colab will help you to a large extent to understand experiments as such, because experiments from the benchmark of the literature will create different ideas for you to discuss in the discussion column. So the results, as I told you, should be presented in a way that inspires any reader, because results has got a connection between the discussion and the conclusion and the introduction as well. So when you talk about the results should have a pattern with the introduction and the conclusion. So introduction is going to solve a purpose. You should say what is the purpose of writing the paper, which comes in the introduction. In conclusion, you should talk about the efficiency because of which you got inspired and you wrote the paper. You're concluding the paper. So the efficiency and the literature should be discussed in the discussion area. So the discussion should have all sorts of literature being cited again and again in terms of how you achieve the efficiency. Abstract is again a short form of the paper as well as such. So the whole paper should be written in a small 10 line or 20 line, short gesture of the whole paper should be written in an abstract. And finally, you write a title. So this is the flow. So you should start with the literature, do experiments, write the results, discuss, keep on discussing, come to a conclusion. From the conclusion, write an introduction. From the introduction, you write an abstract, and then you write a title. But we don't go in this particular fashion. We start with the title and we go, but that will not yield a better paper. So always see to that you follow this particular, flow. And English is very important in terms of how you write the paper, because technical English is very important in terms of writing papers for a better reputed refereed journals, because they expect that particular vocabulary for you from your side, from as an author, to give a very confined idea of that of your presentation. So that is very important in terms of how you are going to write a paper as such. Next is getting paper accepted. So always see to that the confinement of the paper is very important, and short form of abstract is the title. So you should have the title to be the short form of the abstract. So it should cover everything. That is going to be the impression for the paper. So the first impression of the paper creates more citation. So if you are going to give a good title, probably your paper will be cited more and more because of the content that is being searched in the online. Okay, so please think hard before finishing the paper, because it is going to be very crucial in terms of the citation perspective. So editor, in terms of editor perspective, he tries to learn what is the important issue that we are trying to address. So editor keeps on trying to find from the paper that you are sending what is the important issue that you are discussing. So the issue should be highlighted in the paper after the introduction, so that once he finishes reading the introduction, he should be very confident that the issue is very important, which is of a hot research topic, which will be cited by more people, and it will be useful for a lot of people in the society. So addressing in a lucid manner is very, very important. So how we address in a very lucid manner, it should not be going too long. Okay, so the reader should be interested till the conclusion of the paper. So you should keep on reading, and again you should try to get ideas of how you can implement the paper as well. So avoiding things in the paper is mostly about the boasting of your own literature or your own work. Don't boast anything in the paper, and it should be of the simple English. So mostly please write simple English and don't give sweeping generalizations. And sloppiness in the presentation of the text with respect to the fonts and other formats should be taken care. Okay, so we should not keep giving random ideas. It should be very crucial. It should be very confined to what you want to address. When you claim for any things that you have done, it should be very given in a very good manner, and you cannot give random ideas that this has been done by me. No, it should not be done. It should be given with a proper proof. So proofs are very, very important for any theorem that you're going to give for any mathematical modeling. And editing is very important in terms of how you're going to give that particular format, because any journal will have its own rhetorical style. So that style should be properly followed. So before submission, we should always be careful how we revise the paper, because revision is very, very important in terms of how we are going to understand the paper and how we are going to submit the paper in terms of your own clarity. So the clarity should be very confined, and it should be very good in terms of how you are going to approach the problem and how we are going to give the solution for the problem. It is very, very important, and we should be very careful in terms of how we are addressing that particular aim and scope of the journal, as I told you earlier. So it is very important, because once you cross that particular phase of the editorial process, you are probably going into a phase where you will definitely get a comment. Once you get comments, it is very it will create a confidence in you, because once you keep on replying for those comments and trying to apply those ideas that you are noted down in your notebook and apply them for different questions and comments that they arise will create a better quality paper. So revision is very, very important and should be taken very, very seriously. So it should be a routine, and the comments are here creating an opportunity for you to create a better whole manuscript. So coming into machine learning now. So machine learning is as we previously, before I'm going to start with this topic, I understand that a lot of people would have discussed on machine learning. We have heard about machine learning in different places, but basically understand that the computer program is said to learn from experience with respect to some class of task and performance measure. If its performance at task in T as measured by P improves the experience E. So here Tom Mitchell means that, so with every experience, the performance of the algorithm depends on the data as such. So the data creates an experience for the algorithm to keep on evolving itself. So that is why we call this machine learning. Okay. So how we can define a problem, because when we think about problems, we should understand what are the applications, because the application creates an idea of how this problem will solve. And how it will be very important in terms of addressing this particular issue. So here you can see that in machine learning there are a lot of types like supervised, unsupervised, and reinforced learning, and each has got a lot of applications. So like diagnostics, population growth prediction, estimation life expectancy. So there are a lot of applications in different types of machine learning algorithms. So we should understand that each one is a problem. So this defining of the problem starts here. So we should start understanding what is the problem. Okay, so once you understand the problem, we can understand we can try to find what is the literature that is available, and then search for those literature and apply them for a good mathematical model that you can give a solution for that particular problem. So one advantage of machine learning is already a lot of mathematical modeling is being evolved. A lot of modeling has been done already. So it is easy for us to take those models and work on them, because when we go into confined level of the types of the machine learning, it's basically labeled, unlabeled, and how the process of learning gives rewards. So this is going to be applied in different domains, in different verticals. So we should understand how this classification and clustering is important in terms of analyzing the data itself. So we should always, when you get the data, please look keenly on the data itself, because we have data sources like Kaggle and UCIs. We have a lot of other places where you can search for data sets. So data sets, you should take time in watching the data. You just keep the data and keep on looking at it, because that will create an idea of how you can solve the problem, because the data should create different ideas in you, okay, in terms of how it is coming into a supervised learning or unsupervised learning, or it is reinforcement learning. What is the approach towards which that particular problem can be solved? Because problem definition is very important in research. Once you understand the problem, you will go a little faster in terms of how you can arrive at the results. So we all know about Occam's razor. Occam's razor is one definition given by Occam's, where he said that while we prefer favoring simple models, there is usually a conflict between how accuracy and simplicity keeps on varying in terms of degree. Okay, so accuracy and simplicity is always is a trade-off as such. So if you want to have a simple algorithm, simple way of defining the problem, we always keep on going for we compromise in terms of accuracy. That should not be there. So even when you are increasing complexity, we should see to that the accuracy is being evolved. So in machine learning terms, they call a theorem called no free lunch. So no free lunch means there is no single best algorithm that works very well for a particular domain. So we should be very careful in terms of how we are going to search an algorithm, and how we are going to compare an algorithm, which you can see in this particular slide, where there are different classes of algorithm given in continuous and categorical. So in categorical, most of the algorithms come under they come under KNN. They call them KNN, naive Bayes, and other algorithms that we are able to that is being given in this particular slide, SVM. There are a lot of other models as well, because we should understand. That's why I told you about the data. Once you look at the data, you know which class of algorithm will apply exactly for that particular problem. So problem definition is very, very important. So here we can segregate them into the regression and classification and clustering. So regression classification almost comes under similar terms, but they depend on the data, or what is the data being taken. And also you have another domain called clustering, which comes under unsupervised learning. So for that, we'll go into the definition of regression, because regression is very important in terms of how the different statistical processes which are taken for estimating the relationships between the different dependent variable. Okay, so you have a dependent variable, you have an independent variable. So usually dependent variable is the outcome which comes in the y-axis of that particular the graph, and the other way you can look at the independent variables, which are the features. So you can have features of a person. Okay, so what is the income, what is the name, what is the height, what is the address. So these are all different features for a particular person. So this comes as an independent variable, which is going to be dependent on the outcome. It may be the outcome may be whether he can be selected for a particular company or not, whether he has got some taking different features and trying to find whether he has got a disease, taking different features and trying to find whether he'll get a better income, taking different features and try to find if the vehicle will give better mileage. So these are all when I talk about the better dash, that becomes the outcome. So the outcome variable is very important because it is dependent on a lot of other features. So it is important we understand the regression problem as well. Okay, so usually it is y is equal to mx plus c, and that's how we take it into account. But when we are applying for real-time problems, we should understand how it is going to impact on different real-world problems. Okay. So this example, as you can see, it is giving you an idea of how the income and the savings that can be achieved with respect to a person being in a high-risk area or a low-risk area. And similarly, you have a vehicle giving a particular mileage and what is the price for that vehicle. Okay. So next is clustering. Clustering, we all know that we can because a lot of real-world problems, they are mostly coming under a clustering way of analyzing the particular problem. So here it involves grouping of data into categories. So based on some measures of inherent similarity of distance. So you'll have some distance from the the distance is going to give you. It's usually called equilibrium distance from the mean of a particular category of data that you're taking, and you can apply them. So a small example I would like to show here. So this is a TensorFlow projector, which is given by the Google, and you can see we can create a lot of the way particular clustering is done can be seen very clearly in terms of the tensor values. So I give you a small example of how MNIST. MNIST is a very big data with all the numbers being written by different people. So those MNIST data is taken and it is created as a projector for you to visualize how clustering is being done. So usually when we are writing any number, each one can write numbers in different way. I write 1 in different way, 4 in different way, 5 in different way. So each of us write different ways of numbers. So how we can cluster those numbers even when a new number is coming up, and the machine learning algorithm should try to find the number in a particular area. So as you can see here, this color map, I can give a color for this, and you can see how this clustering is done here. So 9 comes in one clustering, and near it there will be 1 or 4, because 9 has got we usually write with 9 as initially with 1 and then put a round around the top edge of it. So like this we can understand how clustering is usually done, and this is how a multidimensional interpretation of any clustering algorithm can be, clustering data can be looked at. So this is how clustering can be done, and you can move this in any form that you want. Okay. So it is very interesting in terms of how these way of representing the data is being established here. So you can go and look at this on this particular link. Anyway, this video is recorded, so you can just type in this and then go to the embedding projector, and you can search, look into different ways of taking different data sets on how they are clustered. Okay. So next is classes of ML algorithm. So class of ML algorithm, we all know the generalized linear models come under the logistic regression. The support vector machines like RBF kernels and artificial neural networks comes for multiple layer perceptrons. Tree and rule based models, you have graphical models, you have ensembles, you have instance based learning. So these are different classes of learnings that can be applied for different data that we are talking about in terms of the supervised and the unsupervised learnings. Here I have another example that I would like to show you in terms of how a machine learning algorithm can be looked into. So before I go into the visual interpretation, first we should understand how the data is being segregated here. So here we have data between San Francisco and New York. So there are houses in New York, there are houses in San Francisco, which is in green. So New York houses are usually a little costlier because of the place and the elevation it is going to be. It is with the sea level, so it is very cheap in terms of how the data is the cost is going to be decided with respect to both these areas. Okay, so San Francisco is in green and New York is in blue. So adding nuances, as you can see, this creates a particular scatter plot for all the different the houses that are there in San Francisco and New York. And San Francisco, as you can see, it has got elevated homes because they are very high. The ground level is very high in terms of comparing the sea level between the sea level. So they are usually in a higher altitude. So the cost is little low. So most of the data that you see here on the top of the scatter plot are usually in an elevated area, or it is in a higher sea from a layer which is at a place which is higher, very high from the sea level. So with this, we can create a lot of the different scatter plots in terms of how the data is being segregated with respect to elevation, the year which is built, the bathrooms, the bedrooms, and a lot of other features that we can take and create a model for it. So this is a scatter plot for different ways of representing a particular feature with respect to the outcome. Outcome here could be the cost of the house, okay, which is Y. So with this, we can create a decision tree, and we can create different boundaries for this. So as you can see, it creates different boundaries, and we can easily find what is the price which is high in terms of the blue color peaks that you can see here. So these are all created with different decision trees. So what is decision tree? We look at what is decision tree now. So here we can see that 111 houses of the data from the New York from the total data set is falling under New York, and the other falling under San Francisco, and we have some wrong data as well, errors as well. So we should also try to find how we can find the error. Okay, so error in data is very important because the errors can create a bias and can also create the variance, which can which can change the whole outcome as such. So as you can see, once you can properly create a better decision, because here the decision earlier the decision was different. As you can see, earlier the decision was around 91 feet. If you are taking 91 feet, okay, so if you are taking 91 feet as the decision boundary, then probably 82% of the data is correctly classified. So it is very important to find that particular decision to understand how we can segregate between different data. So we look at the tree growing. So here, as you can see, the tree keeps on growing, and from a sectored graph, it keeps on going to a whole scale graph. So it either becomes whole green or whole blue. It is because it is reaching a better conclusion. If it does not have a better conclusion, it is either partly blue, partly green graphs. As you can see, it keeps on evolving, and finally we reach to a particular level where it reaches 96% accuracy in terms of finding whether the house falls under San Francisco or New York, and it exactly segregates or classifies between how this data is being accurately it's able to classify between these leaf nodes and try to understand how a decision is being taken to exactly classify between the houses that falls under San Francisco or the houses fall under New York. Because why we are going into this classification? Because we are more concerned about the new data that is going to come in. Because already a data which is there with us creates a data set, and it is going to be an evidence of how we are going to apply this evidence to find an a priori, or it is going to classify that particular data and try to understand how this data is being seen. Here it's beautifully visualized as it creates trees between different data it is creating, and you can see that when I move these lines, it is going to create different decisions and create different segregation between green and then blue, because green is going to be San Francisco and blue is going to be New York. So this is how it makes prediction. Even human brain, we are trying to imitate a human brain here and try to create a particular training accuracy with all the evidence that is there as a data set, and we are going to exactly classify this particular data. Okay, so as you keep on going, so finally you can exactly reach at a particular level where it is able to classify all the data. Okay, so usually data are being segregated into training and test data. So test data is usually applied for the training data, and it is trying to find how that particular training data is going to give an accuracy, because usually test data will have some discrepancies in terms of how San Francisco data is being improperly segregated, or how New York data is being improperly segregated based on the cost and the elevation. Because sometimes a less cost house may be given to a New York, which is an error data, probably with all the test data that we have. Because we cannot also come to a biased conclusion, because in terms of bias and variance, we should be very careful in terms of how we are going to come to an outcome. Because when the complexity keeps on increasing, you are going to probably increase the variance, and when the complexity keeps on decreasing, you are probably going to increase the bias. This is a major problem that we have to face, and we have to come to a local minima for this to understand a better outcome and to give a better conclusion of the decision that we are going to take. So coming back, ML algorithms, as I already told you, can be classified into these types, and as you can see the representation here, which clearly tells you how the data is being segregated in terms of the different regression and the k-means, the clustering techniques. So clustering techniques, as you can see, the random forest, which we just now saw in terms of how the decision trees are being created. So it creates these decisions based on the evidence from the data set. And support vector machines usually take some hyperplane, and they try to take the Euclidean distance between them. And naive Bayes takes the Bayes theorem, and it tries to find an a priori of the probability that probably a particular data is classified in a particular form. So we should understand that these algorithms will apply and will play a crucial role in terms of how we can apply them. So basically, what do we require to do all this? So coming to the requirements, so up to now, whatever I've spoken, we can apply them in a real-time environment. So for this, we have something called Colab, as I already told you, which is an open source tool. So the Colab, I've already opened that that particular thing. I'll show that to you. So here we have this the Colab, the test bench, and you can here to go into this, you just have to go to my drive. You just go to Google Drive, and here we can just click new, and then go to more, and then you have something called Google Colab here. Okay, so you just click Google Colab, it will directly take you to this particular page. So Google Colab, I'll open that and show you. So you can directly access Google Colab from your Google Drive, because The problem with the Python and how we implement Jupyter is it takes little time for a standalone device to install and then start working. But here the Google Colab is very prompt, and you can easily work on this directly from your Google Drive. So you can save all the data in your Google Drive and then you can work on them. So this is very handy tool for you to work immediately by today evening after I complete this slide, and start working on this particular on any problem that you're interested in. Okay. So before I go into this, let me see from some few papers in Google Scholar. As you can see, this Google Scholar, this is a website which gives you different papers, good journal papers which are there available all over the world. And here I've just typed as a keyword machine learning leaf disease, and you can type anything. Okay, so here you can see a lot of papers. This is one of the paper which I recently saw, and it is being cited by 12 people. Okay, so it is very important that we look at those papers and try to find how they apply these methods for finding different solution. Okay, similarly for deep learning, there are different papers that you can see, and how we apply them for a real world problem. Like suppose if I take this particular paper, you just go into because this is cited 3 not 2 times. Usually citation is given below the paper itself. This citation is very important in terms of how this research is creating a breakthrough in the recent research. Because the more the people cite, it means the more this paper is being read and cited in their own references. Okay, so when I look into this paper, as you can see, they have discussed more about different algorithms. As you can see, the different disease names and how they are applied with different algorithms, and they come with different solutions like AlexNet. Okay, AlexNet is an important algorithm in the deep learning paradigm, where you can apply different parameters and change different hyperparameters and reach at a better accuracy. Because accuracy and success rates in terms of the number of iterations that particular algorithm is going to apply will help you to reach better results in finding what is the disease that is being attacked on the plant as such. So this is one example. So similarly, you have a lot of other examples as well. So you can just go through them and try to find how it is applied. Okay. So I open one more paper. I'll just look into that. Okay. Hello. Hello.
Yes.
There is a small data problem. Okay. There is one more thing called facets. So this is again analyzing how we can look at the data as well. Okay, so this is again provided by Google. You can go into the facets thing given by them, and you can just apply your data into this. You can just bring in your data and try to understand what is the features and how these features overlap, or how it is going to be a very important parameter to the decision of the outcome. So can be analyzed using facets. So this is another important app or website which you can use for understanding that particular thing. So coming to this the data sets. Okay, so data sets, there are vast data sets in Kaggle as such. So Kaggle and Colab is very important in terms of research perspective, because both are open source and both are given by Google, and you can apply them in your day-to-day research. So here you can see how this is a Kaggle website, and you can see there is a competition being hosted by different companies, and they ask you to give new ideas for finding how a particular driver is distracted. So this is a simple problem which is currently available in terms of the data. So you can try to take them and solve. But similar to this, we try to do a conference paper, which I'll show you now. So this is my paper, and we try to find how an intoxicated driver behavior analysis can be done. So for this, what we did was we just this code I will just show you. So this code is available on GitHub on my name. You can just go and search for it, and this code is already available. So you can just take this code and try to run this. And as you can see, you can run this directly on Google Colab. That's what I wanted to show you now. So just you can click this. You can bring this code here. Just click this, and if you are able to connect to it, probably this will run. Okay. So let it keep running. I would like to also show you how you can bring in this, this particular data set, like this particular data set. So this is just now, as we saw the house prediction between the San Francisco and New York data set. So similarly, we have another data set called Brazilian houses to rent. So how much rent is being collected in terms of the data set is being given here. So this data set is being downloaded by I tried to download this particular data set and apply this on Google Colab. So I'll just show you a demo of how it is done, and you can just try to do it on your own. Okay. So for this, what we have to do is just go into the Kaggle data set and try to first understand what is the data, because the data is given here. So it is 1 MB data. Also see that there are some data sets which are very heavy, which are 5 GB, they're very heavy as well. But anyway, you can use Google Drive to shift this particular data to your own Google Colab from the Google Drive, and then apply them for different algorithms, and you can work on them. So here, as you can see, this is the data which is given here. So there is a city, there is an area, there is rooms, there are bathrooms, there are parking spaces, floor, animals, furniture, there are a lot of things, and then finally they try to find what is the rent. Okay, so the rent depends on these different features of the data set. So we'll just apply that into this. We'll bring that particular data set into our drive and then work on it. So for this, very easy. You should just type these 2 lines from google.colab import drive.mount. Just click this, and it will transfer that particular data from the Kaggle data set, and you can bring that into your Google Drive. So for this, you have to first create a small folder called Kaggle in your Google Drive, and then once you type these 2 lines, okay, so from Google Colab import drive.mount content G drive, just type this, and you will get that particular data set being you can import the data set from the drive. Okay, so for this, you just click on this, and it will take you to another tab with it will ask you for permission, and just give that permission, and just click allow, and just copy this code, and you can just paste it on that particular authorization code. Okay, just paste it here and just click enter. So once you do this, it will automatically authorize you for using the Colab from the your own drive, your own Google Drive. So once it is done, it will show you mounted at this particular thing, and just go into the next code called import os.environ. So it is going to take a particular environment from the Kaggle, which is going to be a Kaggle.json file, and we have to copy this and save it in our own drive, which is having a folder called named Kaggle. So as you can see here, since I've already done it, I will show you where is the folder for now. Yeah, so this is the folder which I created the Kaggle, and I'm transferring that particular file from the Kaggle into the Google Colab. I mean Google Drive. So once it is done, you can immediately you can find the position where it is. So it is in content. Okay, so you can find where is the drive Kaggle, the link. So it is in content, G drive, my drive, and then there is a folder called Kaggle in my own drive. Okay, so once it is done, you can just find you can download the data set. Okay, so for downloading the data set, you have to put this command, give this command, and then you will get into this particular this Kaggle data set can be brought in here. So for this, before going to this download -d into this, please remember that you have to copy this particular API. So there will be an API here. So you just have to copy this API command and then paste it there. Okay. So once you do it, you can easily bring in that particular data set here. So once we have downloaded it, it will show you what is the data sets that are available. As I showed you, whatever is there in folder, it is exactly showing me on this. Okay. So I already unzipped it, so I'm not running this particular command. And then directly you can start working on the code as well. So in Python, NumPy and Pandas are very important libraries for you to work on the processing and how the data is being looked into. So I'll just run fastly, saving time, and try to show you some inceptions of how this data is being read. Okay, so all this data is available on my GitHub, so you can just go into GitHub Anandarajan and you can find all those data here. So all these code are already available. I'll show you all those codes as well. Okay, and the end of the slide, I will also share you that particular links. So after doing all this work, okay, so you can find that it is showing you all this data that is being taken from Kaggle, and it is showing you what are the different features of the data, which are object and integer types. Okay, so city is object type, area is integer type, which is a number. So there can be some floors with respect to the names, some animals with names. So it depends on what is the object file, what is the integer file. So it is categorical. Okay, so those category can be seen here. So as you can see, there's a different numerical features. These are different object or categorical features. So once you apply them, you can go into the confusion matrix of how this data is being looked at. So as you can see, the range of 1 means that it is very highly important feature in terms of how we are going to predict the rent. Okay, so as you can see, the more the green and red, it is very important to see that that particular feature is going to contribute to the outcome deviations. Fine. So yeah, so once you do that, so you can run the correlated values. So we can correlate between different features that are required, and then create a pair plot with respect to different features, as I showed you in the previous virtual simulation of that particular machine learning algorithm. Same thing can be done here with just one line of code, SNS dot pair plot data correlated. So once you do it, whatever features that we brought into correlated columns will be shown to you with respect to different other features which are very important in terms of how different data are being scattered in that particular feature. So as you can see here, so there are different features here, as you can see. So the rent amount is compared with different features, and the bathrooms are compared with every other feature. The property tax is compared with every other feature. Okay, so like this we can compare. So once you do this, you can get an insight of how the data looks. Okay, so like this you can keep on comparing between what is the number of rooms and what is the rent amount. If the number of rooms increases, the rent amount obviously increases. And there are some features which are very high in terms of small rooms as well. So it depends on the location and other features that we are talking about. So for this graph, as you can see, there is only one line that we used to easily create a graph here. So Python is another important programming language, which is very handy, and it is very important for us to understand how we can create intuition of the idea that we are looking into. So here we are comparing between animal and city. If animal is being accepted by the owner, then the number of count of the houses are being shown here. If it is not accepted by the owner, house owner, it is not accepted. So how many are not accepted? How many are accepted? So these are being shown here. So like this, we can compare different data and try to create different graphs with single lines. Okay, I'll also share this code to you, don't worry. So but here what is crucial to understand is Google Colab gives you an immediate test bench or the tool to work for you immediately as soon as you complete this session. Okay, so immediately start working, because once you delay something, it will take you to longer time, and coming back to the same position takes more time. Please understand and try to implement those then and there. So categorical, as I told you, the feature the object data are being displayed here. So like this, you can keep on running between. So I've run all these codes with respect to the data as well. So I'll go into the algorithms now. So like this, you can keep on comparing between different data. So once you do it, yeah, so you get something called sklearn. Okay, so this is scikit-learn model where you can implement, we can compare between different algorithms which are already there as a library. So once you import, so like a decision tree regressor is one of the algorithm which you can run and try to understand how decision tree regressor tries to accurately predict between the training models which are given by X and Y, and then how it is tested and giving you a particular accuracy for that particular decision tree. So as you can see, it is giving you 99% accuracy in terms of how the data from the Brazilian data set is being segregated, and it is exactly finding the rent that is being asked by a particular owner, and how it is changing with respect to the different features it is showing you. Okay, so like this, you can create an image of the particular the data that is being created, and you get it. In this, it actually creates a decision tree for you to look into. It will take some time because it has to run through all the features and create a decision tree which is going to exactly find the decision with which it is going to segregate a rental which is much higher or much lower. Another algorithm is random forest regressor. So this is another algorithm which is which is also available in sklearn. Sklearn has got all different algorithms which you can compare directly from the particular the toolkit, and you can use them to apply them for different data sets and try to find the accuracy for that particular data set. So let this run. I'll show you once it is finished running. It will take some time. Once it is running, it will show you how much is the disk space and RAM disk that is being occupied by virtually by the Google Colab. So it is also showing you. And another advantage is you can have the runtime type and the you can implement different GPUs and TPUs here with respect to the amount of data that is going to be used. So you can do that in Colab as well. Okay, so you can apply them. So once it is run, it will show you the accuracy within which a particular algorithm is going to be segregated. So as you can see, it is very small here. If as you can see here, so these are all small decision trees that are being created. Okay, so there are 7,200 by 7,200 figure size. So as you can see, there are so many features being scaled down, and it is going to be creating decisions with respect to these different data sets. So this random regressor has given you again 99%. So like this, we can keep on running between different regression. Linear regression has given you 97%, which is little lesser than other algorithms. And SVR, which is support vector regression, again it is giving you 60.6069 because it is not able to exactly find the hyperplane here. So it is going to not give you a better approach here. So like this, if you keep on comparing all these algorithms, finally you will get a comparison like which algorithm is better. As you can see here, SVM is at the bottom and RFN is there. Random forest is doing much better than every other algorithm. So this gives you an idea of how you can write the paper. So similarly, I've run this driver data set for my paper, and I've run this program, and I don't want to run this whole thing because of the lack of time. So as this data is already available, you can check this on the Google, GitHub, and you can once you run this, I got an idea of how to write the paper. So coming to the paper, so as you can see here, this particular data set that I've taken, okay, so I'll go back to the slides to show you what I did. So yeah, so motivation was the different accidents happening around Hyderabad, because at that time I was in Hyderabad. So I looked at the data sets that are available for Hyderabad, which was very tough for finding because there were not much data sets available. So we took a random data set and we tried to match it with the available validated results. As you can see here, the steering wheel goes between -600 to 600 degrees. Engine speed is in RPM, and then you have another metric which is in kilometer per hour, which is the vehicle speed. So this is the data set that we have taken, and this data set is being applied in terms of different sensor inputs that are taken, and we are applying different algorithms for this, as I showed you in the previous example, and try to find the performance metrics for it. So usually most of the papers that we can see in machine learning and in deep learning, they talk about accuracy and F1 scores. So F1 score is nothing but 2 into precision into recall divided by precision plus recall. Precision is true positive divided by true positive plus false positive, and recall is true positive divided by true positive plus false negative. So this is a confusion matrix of all the actual values and the predicted values. So once you get these actual predicted values from the confusion matrix, you can, as we saw earlier, okay, so you can create these data. So finally I got these results actually. So these are the results I got from this particular code on Google Colab. I ran this on Google Colab and I wrote this paper. So here, as you can see, I have taken that data set. As you can see, this is the confusion matrix. If you want to see this confusion matrix, I will try running it again, because if I show you live, maybe you get an inspiration. So again, yeah, this was done, and here, as you can see, there is a data set I already copied, and it is there in my GitHub repository called driver behavior. So I brought that in here from the GitHub repository. So there are two ways of bringing data sets from Kaggle or GitHub. So you can do both, but bringing from Kaggle is far more easier, what I feel, because in GitHub you have to bring the whole data set into a .csv file and save it as a file there and then bring it. But in Kaggle, it is very easy in terms of how we are transferring it directly from the API into the the Google Colab. Okay, so once you run it, you can see that it is showing you all the data set features that I've taken for analyzing what is the probability that there will be an accident. Okay, so accident is the outcome here. So I'm trying to find the accident with respect to different features which are shown above, like the breath alcohol, the brake press, the steering angle, the vehicle speed, the engine speed, the longitudinal acceleration, transverse acceleration, the yaw rate, and finally it gives you an accident with respect to how these different features are going to change. Okay, so this is the confusion matrix as I showed you. So this is the vehicle speed. I'm comparing between steering angle and the vehicle speed. And finally, I go into the algorithms. Okay, so once I go into the algorithms, as you can see, it is creating a R-square value for me. Okay, so with respect to what is the the features, and it is giving you an idea of how I'm just running all these codes, and nothing that I'm doing. So once you run it, you can see that for random forest, it is creating so many true positive, false positive, true negative, and false negative values. And from this, it is giving you a F1 score and recall score, and it is giving you a precision score, which is much better comparing other algorithms. Random forest is much better in terms of how it is clustering data. Okay, so here it is little lesser in terms of the k-neighbor classifier. So I've just brought in all these results in my paper. That's all, nothing else. This is the conference paper by the students. I told them to do, and they try to do it. Okay, so it's easy for you to easily apply them in the real world problem and try to solve them. So the same results I've brought it into the slides with the idea behind it. And finally, you get an F1 score. So F1 score, F1 score is the final value of the accuracy. Okay, so as you can see, it is around 95%. Okay, so it is better in terms of the accuracy. So final recommendations. Research is fun. First, we should understand that whatever we do, please try to understand that you should make it as a fun, instead of making it as a boring or a tiring task. Please make it fun, because once, how will it be fun? Because it will be fun when you are applying it in various domains of your daily life, because it should be a habit to become a fun. Because when I talk about an academic perspective, I understand it is salary and it is kind of more of sitting in the cabin job. No, it should not be like that. We should try to apply with different projects, try to apply for different organizations for the project applying for different projects, and we should try to apply for different patents. Because what will happen is, once these ideas are keeping on flourishing, you can discuss this with the children. That is where it counts, because once you are discussing it with children, the research gets fun. Okay, so because children will keep on asking you questions. When they keep on asking you questions, it gives you a motivation, it gives you an opportunity, it gives you an inspiration to apply them for the real world problems. So it's publish and flourish. That's what it is. You should not say publish or perish. No, it's not like that. Most of the the slides, or most of the presentations that we have gone through in terms of research, they always talk about publish or perish. It's a little scary in terms of how they're talking about, but I understand it is a problem. But we should always look at as a happy thing, or a thing which you want to do, you are interested to do. Okay, for that there is a lot of patience and perseverance that are required, because it is all about writing. Because when you talk about writing a project proposal for a DST, you have to write. When you're talking about writing a paper, you have to write. When you're talking about writing a book, you have to write. When you're talking about you want to write a patent, you have to write. For everything there is writing. So writing has gone down drastically because of the screen time and the other available screen devices. But we should see to that. We should sit with a desk and pen and notebook and start writing different ideas, and try to understand how a particular problem is defined and applied with different tools. Because tools are the major drawbacks in research with respect to the institution perspective. I don't want to complain in the institution, but again, they are giving the infrastructure for the students and the professors as well. But we have to be very careful with respect to how we are going to apply those tools, because tools may be a licensed tool. MATLAB is a licensed tool. There can be different tools that may be licensed, but we should understand that how an open source tool can create a major breakthrough in the how it can apply for different solutions in terms of newer problems. Okay? So always be thankful to the reviewer, because reviewer gives you takes a lot of time for your work, and sits and looks at your work. Because even my friend or my colleague doesn't take time to look at my work. They get irritated. So it is a problem. I understand it is a problem, but we want a better reviewer, because reviewers are the one who are helping us in our research. So once you send a paper and get reviewer comments, please thank them. Please take those comments as a better productive criticism, because criticism is very important for anyone. Once you are not criticized, you will not develop. Once you are not questioned, you will not develop. Once you are not applying your work, you will not develop. So it is always important for us, for in terms of developmental productive future, we should always be criticized. Once we are criticized, we can easily understand where we stand. We can easily understand what we should develop. We can easily understand what are the skills we should develop. So once we do it, we can keep on flourishing. Okay. So this once again. So, yeah. So these are some of the references, and I think I've finished little earlier. So please, I would like to ask some queries, and any doubts, please ask me. You can ask me now. I would like to also thank you, the organizers, for having so much patience despite my trouble throughout this particular journey, and they took time to make me understand what is this particular this go meeting, if I'm not wrong. Yeah, go to meeting. Yeah, I've not used this before, so they told me how to use it, and they've taken pain in helping me with stuff. I would like to thank you, the HOD, the principal, the management of the Jeppiaar Engineering College and the Department of CSE for kindly allowing me to present my ideas to different audience. Thank you.
Thank you, sir. Participants, if you have any query, you can now ask or send it in the chat box. Sir, one question in chat box. Sir, KNN
Yes.
can also be used in unsupervised learning. Am I right, sir?
KNN, it depends on the data, because the data what you're going to take, if you want them to be more categorical, then probably what he or she said is right.
Okay. The another one, in sentiment analysis, how the text or data will be converted, if you have any method to convert. And we have many tools like Anaconda, Veha, which tool is better for ML algorithms?
Yeah, that as I told you, the tools are varied. It is available, but if you want to start working immediately, better go to Google Colab, because it's already giving you Python libraries, which is very vast in terms of the libraries that are available with Python. So I don't think any other tool will have a varied dimension of different the tools, the libraries that are available with Python. So you can directly work on Python as a tool. Coming to sentiment analysis, I've not worked much on sentiment analysis, but probably you should try to apply a better mathematical model for sentiment analysis, because there are different mathematical models already applied. So you just take those models and try to fine tune it with different hyperparameters, and probably can achieve a better accuracy.
Okay. The next one, sir. Sir, how to convert CSV file to image?
CSV file to image. No. CSV is a comma separated version, so it is a tabulated file. Probably most of the data that are there, which are not image, fall under CSV. But if you want to, I'm afraid I don't understand the question. But anyway, if you want to convert CSV into image, I'm not sure. I'm not exactly sure about it. But CSV is a comma separated version file. So whatever you can create on an Excel file is a CSV file. So it is a basic Excel file. So you can create columns and rows. So which becomes a matrix, and you can create a lot of data with respect to how we can interpret rows and columns. And with that, you can find any regression parameter like y is equal to x plus c.
So the next one, does Google Colab use GPU?
Yeah, it is. That's what I told you. It's using GPU and TPU. Exactly, I think it is. We are able to look at the slides. It's somewhere in edit, I think. Yeah, notebook settings. So as you can see, you can change the notebook setting accelerator into GPU and TPU. I've not used GPU TPU here because my data is only 1 MB. So it depends on what is the data set. Because if you go into Kaggle, there are a lot of data sets which are as you can see here in Kaggle. I'll just go show you some data here. So in data set, as you can see here, if you want to exactly filter it down, here it shows you in terms of MB and GB. Okay, so GB, if you go into GB kind of data with a lot of images, probably you need a GPU or TPU so to really compute them a little faster, and it helps you in a faster way, because most of the algorithms take 1 hour or 2 hours in terms of the machines that you use, but Google Colab helps you virtually on a cloud run these TPU GPUs for you, and it gives you the results. But there is also a threshold for it. Please look into the threshold, and also Google Drive supports you with only 15 GB data, so we should be careful with the amount of data that we are going to use, and how we are going to bring in that particular data set. I understand there is some threshold limits here, but please try to work in a data set which is little lower for research at the initial pace. Later, maybe when you're coming to a thesis level or synopsis level, we can go into a better bigger data set and try to get better accuracies.
Okay. One kind request participants, since today is the last day, please be patient for 10 more minutes. So next question. Sir, can you name few algorithms or machine learning for which researchers should look into?
Yeah, because algorithms, as I told you, as I listed you, there are a lot of algorithms in terms of how it is looked into, because there are ensemble forms, there are hyperplane forms, there are clustering forms, regression forms, there are different ways of looking at the data itself. So algorithms are vast. I will not suggest a particular algorithm, because as I told you, Occam's razor, by Occam's razor, it is proven that not any algorithm is going to give you a better approach in terms of the higher complexity. So you should always find smaller trees, smaller the decisions will help you to reach a better algorithm. Because problem is, when you're going to apply these to a critical environment, suppose you are applying for a braking system. So if the car doesn't brake a particular critical level, probably that particular that vehicle will go into an accident. So it is very crucial in terms of how fast that particular algorithm is going to work. It should not take longer. So algorithms should have, we should always look into the own notation. We should look at how time complex it is, and we should try to reduce it in terms of the number of iterations or number of decision, that is number of levels it is going to take to a particular decision. So it's very crucial in terms of algorithm decision. So I would not suggest for a particular algorithm, but instead go for comparing different algorithms and try to retwine a particular hyperparameter for a certain algorithm and then create a proposed algorithm for your work. That will be more appropriate for any researcher.
The next one, sir, which is faster, GPU or TPU?
Obviously TPU is faster, but most of the problems that are seen in TPUs is probably coming under the algorithms that are being taken, because algorithm decides whether if it will require a GPU or TPU. If you're going to decide an algorithm, please look into what is the the time complexity for the particular algorithm, and then decide a particular hardware to be either GPU or TPU.
The next one, sir. Sir, image processing can be done using MATLAB or Python. While publishing paper, editors have any preference over the programming technique?
Yes, very much. They look at what is especially in image processing, they look at how the accuracy is established in terms of the different pre-processing techniques that you apply for that particular image. And when you're applying those different modules for that particular image, is it disturbing the mathematical model will also be looked into. So we should be very careful in terms of how we are looking at the mathematical model of the particular pre-processing techniques before we are arriving into the final conclusion. Because what happens is, even the tool is not a problem in terms of decision of the selection of the paper, but they will look into the benchmarks, because once the benchmark is done using a particular tool, they'll expect you to do the same work in the same tool, because benchmark of image processing of a certain algorithm could have been done on MATLAB. So it is better when you're comparing that particular benchmark to use MATLAB. I would suggest that. But anyway, but in terms of tools, you can use both. You can use any tool for image processing. It's not a problem. But please be careful with respect to the benchmarks.
So the next one, how do I use Google Colab for machine learning?
That's what is the whole presentation. So you should maybe take some code from GitHub and try to run that particular code on Google Colab first, for initially for a starter, and then try to retwine your hyperparameters for each and every algorithm, and try to change that particular algorithm for your own design with mathematical modeling, and create a paper of your own.
Okay, thank you. So the next one is probabilistic logic use naive Bayesian classifier.
Sorry, ma'am, come again.
Is probabilistic logic use naive Bayesian classifier?
Yeah, probabilistic. It is very much probabilistic in terms of naive-Bayes classifier, because the naive-Bayes classifier takes in evidence to find the a priori or posterior probabilities for any decision it is going to take. So usually the naive-Bayes takes an idea of, for example, I give you whether it is going to rain if it is cloudy. So it will immediately try to find if is it raining because of cloudy, or is it raining or it is cloudy since it is raining. So it depends on how we are deciding between different decisions probabilistically, because probability is very crucial in terms of machine learning. Most of the decisions are mostly probabilistic, and it is going to take some evidence to decide at what is the posterior probabilities that we are going to achieve.
Okay, so the next one, how is KNN different from k-means clustering?
Yeah, k nearest neighborhood is going to take a particular the Euclidean distance. It is depending on the distance, Euclidean distance, because that's why it is called nearest. And the k means is going to take a mean value for a particular centered cluster, and that mean is going to help in clustering all the rest of the data in the data set towards it and cluster it. Mostly k means we can apply for clustering algorithms. KNN also can be used for different nearest neighborhood algorithms, but it depends on the data set as well. So if you're going to use a particular data set, maybe in terms of images, a particular k means will it will work better. So it depends on what is the data set that you're going to use and how accuracy is going to be predicted with respect to the preference scores.
Okay, so the next one, what are the steps involving the machine learning?
Yeah, steps usually you have to take a take a data set. You have to clean the data set. You have to visualize it. You have to understand how the data is going to give you a particular prediction, and then apply algorithms and then fine tune the hyperparameters, and finally come with the better approach for that particular problem, and give a pattern of how the mathematical modeling is giving you the algorithm and the results. This is the usual pattern.
Okay, the next one, what's the main difference between entropy and information gain random forest algorithm?
Yeah, entropy is nothing but how much data is going to give you a particular probability with respect to the positive and the negative values. Black and white are a positive and negative. Okay, you have either a zero value or a true value or a false value. So this true and false is going to decide based on what is the data as such. So the entropy is going to give you a particular measure of these probabilistic approaches, and it is going to give you an information about it. What was the next thing, ma'am? Information gain.
Yeah, yes, sir. Information gain random forest algorithm.
Yeah, so information gain is going to give you the total information that you got from that particular feature in the random forest algorithm. So when applying features in random forest algorithm, so that particular feature will contribute more to the outcome. So if that particular feature is contributing more, because it is multidimensional, so if it is multidimensional, we all know it has to go through different gradient descent. So those gradient descents will help you to understand which is the best global minimum, because local minimum can happen for different features. We are not concerned about the local minimum, but it also contributes to the global minimum. But those local minimum will help you to reach to the particular global minimum, which is very crucial to decide on the particular outcome. Yeah.
Okay, so the next one, sir, KNN is supervised and K means is unsupervised ML. Am I right, sir?
No, I don't get the question.
KNN is supervised and K mean is unsupervised ML. Am I right, sir?
Yeah, I think I've already answered this. K means KNN and K means is coming under. It depends on what is the algorithm and what is the data set that is available. So if it is having all the features given to you, it becomes supervised. If the features are not given and you have to predict with respect to what is the data that is given, it becomes unsupervised. So it depends.
The next one, sir, can you point out related to precision and recall?
Yeah, precision, already I told you, precision and recall is a trade-off actually. Once you want to increase the precision, recall goes down. Once you want to increase recall, precision goes down. So it is kind of a trade-off, and both these measures contribute to the F1 score. So we have to calculate those precision, recall from the true, positive, false, all those actual and predicted values, because actual and predicted values keeps on changing depending on the training and the testing data set. So this training data set, once it is clearly giving you better outcome, the testing data set will disrupt the whole idea of what we were trying to analyze. So this will give you a contribution towards the confusion matrix. So the confusion matrix exactly tells you what is the predicted value and what is the actual value. So this keeps on changing actually. So this predicted value is from the data set, training data set, and the tested value is the actual value that you're going to get.
So last question, is there any difference between probability and likelihood?
Yeah, there is very much difference between both of these. Probability is going to give you an idea of what is the chances that you're going to look at, but likelihood is a way of understanding that that particular path is going to give you a better approach for the rest of the data sets that are going to come up. So probability may change with the data sets that are coming up, but likelihood is less likely to change. So maximum likelihood will give you estimation will give you an idea of how a new data set, new data that is coming in with every real-time data to create a better approach towards the outcome that is to be predicted.
So one more question is there.
Yes,
in image processing, using supervised classification, we can have ground truth information or image. But for unsupervised classification, what are the methods available for generating ground truth information for performance analysis like PP, TN, FP, and FM?
Yeah, that's correct. The ground truth is very strong in terms of supervised learning, because we know that the data set is going to give you a particular outcome with the features available, but the features in supervised unsupervised learning is very random, and you have to be very crucial in terms of the ground truth, because ground truth changes in terms of the unsupervised learning, and it's better to look at the benchmarks. As I told you earlier, benchmarks will give you an idea of ground truth in unsupervised learning, because unsupervised learning will already give you an accuracy with respect to certain algorithms which are already published in the research arena. So we should take them as a particular validated result and try to apply our algorithm towards the outcome that is to be predicted for image processing.
Sir, one more question is there. Which is more important to you, model accuracy or model performance?
This is a confusing question, because what happens is performance will lead you to accuracy actually, but it's a subset of accuracy. So if you don't have better performance, you cannot have a better accuracy. So I cannot exactly answer this question. Yeah.
Okay. Participants, please wait for a few more minutes. We have the last day, so we have formal closing session is there. Please wait for a few more minutes. Thank you, sir, for clarifying all our doubts.
Thank you.
And thank you very much for accepting our invitation and the detailed presentation on research perspective on machine learning techniques using Google Colab. Yes, sir, it's really the session was very informative, interesting, and useful in gaining knowledge on the topic. We are sure that every participant would have benefited from today's session. Thank you once again, sir. Thank you, sir. Now, I request our HOD, Dr. Jeppiaar, to share a few words about this FTP.
Thank you, Dr. Anandarajan, sir.
Thank you, sir.
Very, very interesting and informative session regarding Colab tool as well as research perspectives. Both were very nicely handled by you. So I hope all the participants would have benefited, gained knowledge in this area. Very nice session, sir. Thank you all participants. You have paid a lot of and lot of support, lot of interest you have shown towards our faculty development program. I once again wholeheartedly thank each one of you, international participants and participants from Tamil Nadu. So I really thank for you for showing interest in our faculty development program. I congratulate the organizers for organizing this faculty development program in a smooth and very well planned manner without any bias. Uh, so this we have come to the end of this faculty development program. So the videos are available uh, and the video links will be shared through your WhatsApp group as well. We are having it in our Facebook page also. So those who prefer, the organizers will share the videos of recorded sessions of this faculty development program for the entire 5 days, so that any doubt in future you can view that video for techniques that the speakers were pointing out about. And so I take this time to thank our management, chairman and managing director, Dr. Regina Jeppiaar, for being the motivational pillar behind this event. So her support and motivation was fantastic. And I thank our principal, young and energetic principal, Dr. V. Natarajan, for supporting us and guiding us to organize this faculty development program. I once again congratulate and thank all the department faculty members, computer science and engineering department faculty members who jointly made this event a great success. I thank the participants, international and Tamil Nadu participants for showing interest in our faculty development program, allocating time in this lockdown period for learning. So it is quite impressive. So keep on learning. So COVID can restrict us from moving out of our home, but COVID can never restrict us from learning. So that's why we organized this event in this period of time. So it's an opportunity for us to sit in our home and learn. We have more time now to learn. So keep on learning. So more webinars you have from all the colleges of Tamil Nadu. So you participate, you keep on learning, upgrade yourself when you go back to your college. So kindly don't forget to transfer this knowledge and the information that you gained for your students. So that's what the ultimate purpose of this faculty program. Whatever knowledge and information that you have learned, kindly take forward it to your students and share the information to researchers, other researchers, and make use of these session information for doing a very good research. Best of luck, and thank you all once again. With this, I conclude my note on this special occasion. Thank you all.
Okay, thank you, sir. Before we close the FDP with vote of thanks, we would like to hear from you too. Anyone who is willing to share their feedback openly about this FDP may please unmute the audio and speak now. We request you to be precise and short so that we can hear from as many as possible in the short time before us. Anyone, please, if you have any feedback, you can share now.
Hello, ma'am. Hello.
Yes, ma'am. Yes, yes.
Hello. Ma'am, I'm Shakuntala from Government Polytechnic. Hello.
Yes, ma'am, please.
Hello.
Yes,
Ma'am,
we
I'm
can hear.
Shakuntala from Government Polytechnic. Hello. Hello. Hello.
We can hear. We can hear. Please, ma'am.
Ma'am, I'm from Shakuntala from Government Polytechnic, Bagalkot, ma'am.
Okay, ma'am.
Hello.
Please,
Ma'am, I'm
share
from the
feedback.
electrical side. I don't know about much more about the programming languages. By attending these FDP, I know everything about the Python and the machine learning language. It is a very informative session for me, ma'am. And it is a very helpful for our futures, ma'am. Thank you, ma'am. All the sessions are conducted very neatly and in an exact accurate time, ma'am. So how to attend the sessions very nicely throughout the week, ma'am. Thank you, ma'am, for arranging such a wonderful of the FTP to our college, and thanks for the coordinators and organizers and your institution. Thank you so much, ma'am. Okay, ma'am.
Thank you, ma'am. Anyone else?
Okay.
Hello,
Yes,
ma'am.
ma'am. Hello, ma'am.
Hello,
Hello.
ma'am.
Ma'am, Mogana Sundari, ma'am.
Yeah, yes, ma'am. I'm
Hello, ma'am.
Mohana Sundari from Muthurangam Government College, ma'am. I am M.Phil research scholar. This is FDP is very useful, ma'am. 5 days. Learned very new information, ma'am. Thank you, ma'am. Thank you for organizing.
Okay, thank you,
Hello,
ma'am.
ma'am.
Sir, please,
Thank you.
yes. Anil
Yeah,
Kumar, sir.
ma'am. My name is Anil Kumar Maharaj.
Yes, sir.
Yes, I'm from Arunachal Pradesh, ma'am. Right now, I am there, ma'am.
Okay, sir.
Yeah, yeah, ma'am. I would like to thank you all the organizers and coordinating team, especially for arranging such a wonderful FDF session, ma'am. And it was very informative session, ma'am. Thank you all, ma'am.
Okay, thank you, sir. Thank you very much. Any one final feedback, please?
Ma'am, can you hear me?
Yeah, yes. Rajashekar, sir. Yes.
Yes, ma'am. I am from JP College of Engineering, the same resource person as last presented, Anand sir. I am a colleague.
Okay,
Ma'am,
sir.
well, I congratulate the organizers for organizing such a wonderful FDP, ma'am. It is very useful. And we had a session based on that is AI by Noor sir and cloud related activities by Ravinder sir. It is very useful for us. We have learned a lot of knowledge through this, ma'am. And in future, if any, you can report us and you can contact us anytime, ma'am. It is very useful. It's a great, we have gathered a great knowledge regarding this. Thank you, ma'am.
Thank you, sir. Thank you all for sharing your feedback. It is very motivated for us. And we have come to the final moment of this FDP. It will not be complete without thanking all those who have contributed to the success of this program. First of all, I would like to thank Lord Almighty for his abundant grace in conducting this FDP effectively for these 5 days. Next, I would like to thank our Director Ma'am, Principal Sir, and Dean Madam for their vision and direction to all of us. Most importantly, I would like to thank our Head of the Department, Dr. J. R.K. Ranjit, for his unwavering support and continuous engagement to all of us in conducting various events like this. Sir, under your strong leadership and direction, we have successfully conducted many events till now. We are confident of your inspiration and motivation in the future too. I also convey my heartfelt thanks to all the faculty members of CSE department for their hard work and contributions in making this FDP a success. I would like to close with a big thank you to all the participants, both national and international, for your cooperation and active participation during the past 5 days. We are sure that this FDP has added values and have given you valuable inputs to progress further. Thank you once again. Thank you all. May God bless us all and thank you. Dear participants, please note, we will be sending the participation certificate to your registered mail ID on Monday. Thank you. Thank you so much.
Ma'am,
Dhanalakshmi, ma'am.
ma'am,
Yes.
Ma'am, ask all.
yes, ma'am.
Dhanalakshmi, ma'am, can you able to hear?
Yes, ma'am. Yes, ma'am. Ma'am, are you able to hear me?
Yes, ma'am.
TB.
Yes, ma'am.
Sir, Anand sir.
Yes, sir. Yes, ma'am.
Sir, உங்க கேமரா மட்டும் please enable your camera, sir.
On பண்ணிட்டாங்க.
On mind, ma'am.
Okay, sir. Okay. Beulah, ma'am.
Yes. Yes.
Participants, those who are here, kindly enable your camera, please.
Uh, there's a lot of light behind your head. Josephine ma'am.
Yes, sir.
Yes, sir.
Josephine ma'am. There is a lot of light
Okay.
behind your head, ma'am. Close it again.
Okay, okay.
Participants, please, you can enable your video. For taking group picture, we want you all to enable your video, please.
So is it okay now?
Hi, Nada. Chat box will feedback.
Dhanalakshmi ma'am, wait for a few minutes.
Yes, ma'am.
Beulah, ma'am.
Participants, please. Yes, ma'am.
Regarding the certificate, you have to give the feedback for all the 5 sessions, 5 days, or you give certificates to all. Because I attended, but I didn't give the feedback.
Ma'am, I have attended all the 5 days.
Yes, but I didn't give the feedback.
Okay, ma'am. You can contact the organizer, Dhanalakshmi ma'am or Josephine ma'am for this in a private chat, ma'am, after the completion of this meeting.
Okay, fine. I'm not able to I'm not able to send a message privately. Maybe it's blocked or what.
Okay, ma'am. Okay, ma'am. Will be considered, ma'am.
Okay. Thank you.
Ma'am, I have attended 4 sessions, but I missed 1 session. Will it possible to consider it?
Yes, sir. No problem.
Thank you.
All participants, please, you can enable your video for a few minutes so that we can able to take a group picture.
Let's see.
Thank you everyone for joining with us. Dhanalakshmi ma'am.
That is Bindu.
Yes, ma'am.
Yes, ma'am, you can take the picture.
Yes, ma'am, I have taken.
Thank you, participants. Thank you for your cooperation. Thank you all. Dhanalakshmi ma'am, whether the picture is clear?
Ma'am, and the feedback like once again send பண்ணுங்களேன். Rajashekar sir is asking.
Yes, ma'am.
Shall I post, Dhanalakshmi ma'am?
Yes, ma'am, I'm posting.
Okay.
Ma'am, what about our staff?
Okay, no problem. So whether you got the clear picture, right, Dhanalakshmi ma'am?
Ma'am?
Whether you got the picture clearly?
Yes, I have. Yes, it is clear only. I have taken.
Okay. Shall I leave the meeting? Subhasha. Hi, Subhasha. Sir, please unmute your audio.
Yes, madam. We can leave the meeting, madam.
Okay, sir.
Subhash sir.
We'll meet in tomorrow's class, sir.
Madam, இன்னைக்கு டெமோ செஷன் போடணும் மேடம். நீங்க பாட்டுக்கு டைரக்டா எடுக்க விட்டுறாதீங்க நாளைக்கு.
Yes, sir.